Alright, so welcome back to lesson 2. We're dealing with integration by parts. So the last time we dealt with certain questions or questions that were repeated or that could have been used in N5. Okay, so everything that we've done last time is also a repeat of your N5 work. Right, so you must know it for your N5 exam also, if you are still writing N5. Now, from number 19 and then number 21 onwards, those are all the N6 type of examples, but this one can also be in both N5 and N6. Right, so this is the integral of ln x. Right, so you most of the time from N4 you are familiar with differentiating ln x. But now we need to integrate ln x. So integration by parts deals with multiplication. So now this is just ln x, but it's not multiplied by anything. So the trick here is to write it as ln x times 1. Ln x times 1 is equal to ln x. So now 1 can be written as x to the power 0. X to the power 0 is 1 there. Can you see that? Now you go to your priority list. Right, so you go to your priority list, which must be in your head. Right, so the priority list is in your mind, and then you check. Now, what number will I find natural log or even log? Is it number 1, 2, 3, 4, or 5? What number will I find x to the power 0? Is it number 1, 2, 3, 4, or 5? Let's label it. Okay. So what number is ln x? This here is number 2 on your priority list. What number is powers of x, x to the power 0, x to the power 1, x to the power 2, x to the power 3? What number is that? This is number 3. So now, from your priority list, number 1 is the highest up, then comes number 2, then comes number 3. So whichever one is higher up must be chosen as f of x. So now, obviously, this one here is going to be f of x, which is ln x. So I'm going to go f of x is equal to ln x. So therefore, g prime x, once I got my ln x, the other factor is automatically g prime x. So g prime x is x to the power 0. Now what do? I need to differentiate this side, integrate this side, because I want to find f prime x, which means the derivative of ln x, which is 1 over x. And this is g prime x is equal to x to the power 0. So I want g of x. That means I need to integrate x to the power 0. So when I integrate x to the power 0, it's going to be x to the power 0 plus 1, which is 1, all over 0 plus 1, which is 1 in the bottom. So basically it's just x. Right, so now we have all the information. We got f of x, we got f prime x, we got g prime x, we got g of x. We now write down the formula and substitute. Alright, so we know the integral of ln x is going to equal to f of x times g of x minus the integral of g of x times f prime x dx. So this formula is given to you. So make sure you copy it down correctly, but the priority list, remember, you have to know it. You have to know which one to choose as your f of x. So you write down the formula and now substitute. So what is my f of x here? Be careful now, make sure you don't substitute f prime instead of f. So this is f of x, the original f of x that you chose, which is ln x. and then g of x here is x. Remember, g of x appears twice in the formula, so whatever you write down here, you write it down here, which is g of x, you copy it down. And then f prime x is what we just worked out there, which is 1 over x. So what do we do? After applying the formula, you focus on the part with integration, simplify it, and then check if you need to use the formula again. So here, this is going to be ln x times x. There's nothing more you can do here except just swap ln x and x, but it makes no difference. So here, x times 1 divided by x, basically x and x will cancel, and you just have 1. So now, we're just going to integrate 1. Remember, we just integrated 1 before, so there's a check. 1 was x to the power 0, which became x. So now, this is going to be ln x times x minus, and now we integrate 1. We don't have to go and show that 1 is x to the power 0. You know from N4, simply when you differentiate x, you get 1. So if you integrate 1, you get back to x, and now all integration is complete. So you put down plus c. Alright, so that was number 19. Okay, so this example is not in your textbook. However, it's an example that comes about under area, okay, under integration, calculating the area in N5. Normally, they will give you the answer, but previously, I mean, you might be given the answer, but how do you use it? Okay, that's the main thing. We are going to go now and integrate this here. How do we integrate ln x all squared? We're going to use the same technique here because it's just ln x all squared. So what we're going to do is apply the same technique. So we will multiply this by 1. So I'm going to multiply it by 1, but I know that 1 is actually x to the power 0. Alright. Now, we're going to do the same thing. So, what is my f of x now? Let me do my working out on the side here. So, my f of x is, again, I don't have to mention the priority list. You know that ln is number 2 from the priority list, and this is number 3. So, therefore, f of x will still be ln x, but this time it's squared. Right, that is my f of x. So now when I differentiate this, how do I differentiate ln x all squared? We are now revising N5 chain rule. Okay, how do I know it's a chain rule? It's because I have an exponent which is a number. Okay, if I have an exponent which is a number, then it's going to be the chain rule. An example is if I have y is equal to, let's say, sine x to the power 3. And if I want to differentiate this, I will have to use the chain rule. So I'm going to go the derivative of y. So when we use the chain rule, we multiply whatever's in front by the exponent. So that's going to be 3 sine x and 3 minus 1, which is 2 times. So we deal with the exponent first, times the derivative of sine x, which is cos x, times the derivative of x, which is 1. At the end, everything has been differentiated. So this is the chain rule only when your power is a number. But what happens if I have sine x to the power, let's go, ln x now? Now the chain rule does not apply here. Why? Because you have an exponent, but the exponent is a variable like x, or it could be y. So here we cannot use the chain rule, okay? Here we have to introduce logs on both sides. This is log differentiation because I need to simplify, but we will deal with things like this here. So now you know that we have the power, which is a number, so we can use the chain rule here. So the derivative of ln x all squared, 1 times 2, that will be 2 ln x, and 2 minus 1 is 1 times. Just like how I went here. I dealt with the exponent first, and now times, and then I differentiate this and write down the result outside the bracket. So times, now what is the derivative of ln x? 1 over x. Okay, so that is sorted out. There's nothing more to do there. So what were we doing? We identified f of x. So therefore g prime x. So here, so therefore g prime x, you know, is x to the power 0. So I need to integrate x to the power 0, which is going to equal to just x. You know, I just showed you. It's going to be 0 plus 1, which is 1 over 0 plus 1, which is 1 again. So now what do? We have all the information. We're going to write down the formula and substitute. So that's going to be f of x, g of x minus the integral of g of x f prime x dx. So I will write down the formula. Now substitute. Right, so now, what is my f of x? F of x, I identified it as ln x squared. G of x, I just worked out g of x there, which is x. So remember g of x, that is x, and then f prime x. So there's my f prime x here, which is 2 times ln x times 1 over x. Right, there's a 2 times ln x times 1 over x. So what do? We applied the formula, then we always simplify this part here, check if anything cancels, and then we will try and integrate. So this is going to be x times ln x all squared. It doesn't matter, it's multiplication. I can write the x in front or behind. Here, clearly, this x is in the numerator, this x is in the denominator, so they must cancel there. So you end up with minus 2 times the integral of ln x dx. There's my constants. I told you always write down the constant in front here. And now I'm just integrating ln x. How do I integrate ln x? We just did it here now. Can you say that? And now this is equal to x ln. Now notice I'm not writing ln squared x or ln x all squared with brackets. If I decide to leave out the brackets, then the position of the exponents is very important. It must go in between the letter n and whatever function you have here, directly above, written as an exponent, just like you would write down sine squared x. This is sine squared or sine x all squared. Sine squared x, this is the same as sine x all squared, but this is wrong. If you go and write down sine squared x like this, then this is completely wrong, because what's happening here is only x is being squared here. Can you see that? But here you need to work out sine x and then raise it to the power 2. The same goes with logs. Okay, the way you write the exponent. So now I got minus 2 times, I need to integrate, so therefore I need to open up a bracket and I need to apply the formula. The formula here is f of x, g of x minus the integral of g of x times f prime x dx. So now you're using the formula for the second time, but clearly I got my ln x there. So ln x, I'm going to write it as multiply by 1. Okay, so you know how we integrated. Then x, I multiplied then x by 1. You wrote down 1 as x to the power 0. So my f of x is going to be then x, so f prime x is 1 over x, g prime x is 1. Basically, I'm copying down everything that I just have here. Alright, I'm integrating ln x. G prime x is 1, so g of x, I need to integrate to 1. When I integrate 1 with respect to x, it's just x then. So now let's do the substitution. So that's x ln squared x minus 2 I do the substitution. F of x here is ln x, g of x is x, g of x is x, and then f prime x is 1 over x. So now I'm going to remove these brackets, so that will be x ln squared x minus 2 ln x times x there. Here, this x and that x will cancel. Negative times a negative there will be a positive 2 times the integral of just 1. Because remember, x and x cancel, so I ended up with 1 there. And now all I have to do is just integrate that 1, which is going to be x, but since it's multiplied by 2, so it's going to be 2x plus c, and that is how we integrate ln x all squared. Right, so you can copy that down. We're now moving on to the inverse trig functions. Alright, so now for the first time we are dealing with integrating your inverse trigonometric function. Alright, so in N5, what did we do? We did differentiation of this here. So you have to know your N5 work here. Well, I'm going to show it to you now. So in N5 you had something like this here. Y is equal to inverse tan f of x. Okay. Then you have to differentiate this here. The formula for this dy over dx, the derivative of inverse tan f of x is f prime x all over 1 plus f of x all squared. You'll find it on your formula sheet. So an example was if I had y is equal to inverse tan of x to the power 3. Let's take an example. And if you're asked to differentiate this, so now how do you use the formula? You look for f of x and check what is f of x here. It is x to the power 3. So if I want to differentiate this here, dy over dx, then the formula works like this here. Whatever you have here, differentiate it and write down the answer there. So what do we have here? We have x cubed. Differentiate it, write down the answer here. The derivative of x cubed is 3x squared. So I got that part sorted out. Can you see that? So that is sorted. Now 1 plus, so there's my 1 plus there. F of x. Now this is not the derivative, this is the original f of x that you had here. So what is f of x? You copy it down there, x cubed, but now squares. And basically that is it. So now we got 3x squared, and that is 1 plus x. When you have a power raised to a higher power, multiply the exponent, so that will be 3 times 2, which is 60. Let's take one more, just to refresh your memory. Let's say if y is equal to inverse tan, let me go for cos 2x now. What happens if I put a cos 2x there? If I want to differentiate this, so dy over dx, so there's the formula. I identify my f of x, which is cos 2x, so then f prime x now means differentiate cos 2x, write down the solution here. So the derivative of cos 2x is going to be minus sine 2x times the derivative of 2x, which is 2 there, divided by 1 plus f of x, which is cos 2x squared. That's how you apply the formula for inverse tan. Alright, so now let's see how we're going to do it here. So now here, the question is not differentiate inverse tan, it's integrate inverse tan. So remember, you're looking for multiplication, just like how we did ln x. Here, you need two factors here. There's only one factor, which is inverse tan. So what you do is, you will write it as inverse tan x times 1. You know, obviously, 1 is x to the power 0. Now, from your priority list, you know that this is number 1 on the priority list. So if it is number 1, that means it must be chosen as f of x. So now my f of x is going to equal to arctan or inverse tan x. So therefore, g prime x is equal to 1, and you know 1 is x to the power 0. Same thing. You don't have to write down x to the power 0. You can leave it as 1. So now you know that once you got f of x, you need to find the derivative of f of x. So f prime x, the derivative of inverse tan. So now, remember, how do you use the formula? You look at x, which is the f of x part here. Can you say that? So now when you differentiate it, what is the derivative of x? It's 1 plus, then you write down 1 plus f of x, which is x squared. You're clear with that? That is exactly how you use the formula for differentiating inverse tan. So therefore, my g of x, I need to integrate 1 or integrate x to the power 0, which is just going to be x. So once we got this, now we can write down the formula. So the integral of inverse tan x is equal to f of x, g of x minus the integral of g of x times f prime x dx. Let's do the substitution. So what is f of x? F of x is, there's your f of x here, which is inverse tan or arctan multiplied by g of x, which is x. We just worked it out now. Remember, whatever you write down here for g of x, you copy it down here, which is g of x. And now f prime x. F prime x is the derivative there, which is 1 divided by 1 plus x squared dx. So what do? We do the substitution, simplify, and then determine what type of integration problem is this here. So now what can I do here? I can only multiply x times 1 because this is a fraction times a fraction. Remember, x is just x over 1. So it's numerator times numerator, denominator times denominator. So x times 1 there is x all over 1 plus x squared. Now we applied the formula. We need to integrate. We need to remember our N5 integration type. So this here is what I call from N5. I call this one type B. Okay, you can call it type 1, type anything you want to, but basically this type deals with this here. How do you read this? This is a fraction. We are integrating a fraction where the numerator is a derivative of the denominator. Okay, so in a case like this, by inspection, the answer is always natural log. Well, k you know is a number, so it's ln absolute value of the denominator plus c. That is by inspection, which I'm not sure how many of you all know about inspection. So I'm going to use the method of U-substitution. So with U-substitution, we always let u equal to f of x. Remember, the other type we're dealing with is multiplication. This is dealing with a fraction. So if I want to use a U-substitution, let u equal to f of x. So let me do the working out now. So there's your fraction. Here is your fraction. So now f of x is the denominator. So I will let u equal to f of x, which is 1 plus x squared. So now du over dx, the derivative of 1 plus x squared will be 0 plus 2x. Now I need to make dx the subject of the formula, which I'm going to do in one step. If I cross multiply and divide, dx is going to equal to du divided by 2x. Now watch what happens. Let me do the substitution. So I got my x, which is the numerator. Then the denominator has been replaced by the letter u. 1 plus x squared, there's a chair. 1 plus x squared is no more 1 plus x squared now. It's replaced with the letter u. So there's my letter u there. And then dx, there's my dx here. Dx is no more dx, it's now du divided by 2x. So there's a chair. Du divided by 2x. And what we expect is the variable x to be eliminated from this problem. We are now going to be integrating with respect to the variable u. So now you can see that x and x will cancel there. So therefore it's going to be x times inverse tan x. Clearly x and x will cancel. So I end up with 1 over 2 there. And I've still got the u in the denominator. Can you see that? So the 1 over 2, I always prefer to take the fraction and write it in front. And you know I can leave this as 1 over u. Can you see that? So now I can integrate 1 over u. So that will be x times inverse tan x minus 1 over 2 times, when I integrate 1 over u, it's going to be ln absolute value of u. Plus, you must put the two lines there. It's called absolute value, because when we deal with natural logs, we can only take positives, not negatives, especially when we're dealing with area and volume. Okay, then you'll see why these two lines are important. Those are the absolute value bars. So now we're going to go x inverse tan x minus 1 over 2 ln absolute value of u. What was u? Substitute back. U was 1 plus x squared. Now, before you copy down, I'm just going to show you the other method here of doing it by inspection. Okay, so if I want to integrate this here, let's go back. For those of you who can understand this by inspection, very few people can actually do this. I mean, with all the examples, but watch now. This is f prime x and this is f of x. So, if the numerator is an exact derivative of the denominator, then the answer will always be ln of the denominator. Alright, so now, is the numerator an exact derivative of the denominator? No. What is the derivative of x squared? 2x. So what's missing here? So if I write down a 2 there, I must divide by 2 also. You understand what happened there? If I write down a 2 there, I must also divide by 2. Because what was the question, what was here originally? Originally, what number was here? 1. So 2 over 2 will give me 1. So now, this is 2 in the denominator, obviously that means 1 over 2. You understand that? So what is half times 2? It is still 1. I am not changing the question in any way. So now I have a perfect situation. What is the perfect situation? I got my f prime x on the top. I got my f of x, and k is just a number in front here. Can you see that? So if I want to do this in one step, this is exactly how I do it. So now the answer is k ln absolute value of x. So that's going to be 1 over 2. There's my k ln absolute value of 1 plus x squared plus c. This is the method of inspection, where you do not have to use any U substitution. Right, but it's up to you if you want to use it, but you have to know how to do this properly. Alright, so that was number 21. You can take that down. We're dealing with the next one. Our next example, still dealing with inverse trig. Inverse trigonometric function is inverse cos of 2x. So, similar to the previous two examples, it's just inverse cos 2x alone, so you multiply it by 1, and you know that 1 is x to the power 0. So you go to your priority list, and obviously you know that your inverse is number 1 on the priority list. So therefore, f of x is going to be number 1, which is inverse cos 2x. So g prime x is x to the power 0, which is just 1. Okay, so now we need to differentiate here. Differentiate inverse cos, and then we need to integrate x to the power 0. So now we need to go back to chapter 3, N5 work, and differentiate inverse cos. The formula is on the formula sheet, but let's take this one here. So now dy over dx, so the derivative of inverse cos f of x is going to be minus f prime x, all divided by the square root of 1 minus f of x all squared. So that is how we use the formula for inverse cos. Let's take an example. Y is equal to, let's say, inverse cos of x squared. Let me make it more difficult. Let's see, let's make it 3e to the power 4x. Let's do this one here. Alright. So if I ask you to differentiate, let me make it more interesting. Let me put down times x squared. This is like an N5 exam question, right, where we differentiate. So let's read this now. This is inverse cos or arc cos, and then inside here the f of x is 3e to the power 4x times x squared. Right. So now if I want to differentiate this here, first of all, I identify what is my f of x. What is f of x here? My f of x, the f of x part, this part here, is 3e to the power 4x times x squared. So I know now the derivative. So watch this, you're writing N5, you must know how to do this. So now, we start with a negative there, and I'm going to work something out. I need to work this part here out. I need to differentiate it. Let's do the part where there's no working out required. It's just copying down, which is the denominator. That's the square root of 1 minus f of x all squared. This is all copying down. So what was f of x? It is 3e to the power 4x times x squared. Okay, so the part that you're actually working out is always the f prime x part, and you're writing it down here. So what is f of x? F of x is 3e to the power 4x times x squared. So f prime x now, how do I differentiate 3e to the power 4x times x squared? Remember, I'm saying times. When you say times, multiplication, therefore product rule. Okay, so the product rule has to be applied here because you are multiplying this 3e to the power 4x multiplied by x squared. So how does the product rule work? It's going to be f g prime plus g f prime. Basically, write down the first, differentiate the second, plus write down the second, differentiate the first. That is the product rule. So now, f is 3e to the power 4x times g prime. G is x squared. So g prime, the derivative of x squared is 2x plus g, which is x squared times f prime. So I need to differentiate 3e to the power 4x. So the derivative of 3e to the power 4x is 3e to the power 4x times the derivative of 4x, which is 4. That's the product rule done. So basically, this is going to be 6e to the power 4x times x plus 12x squared e to the power 4x. And that's basically it. So that is the product rule. That is my f prime x. And that's an example from N5 where we have, it can be anything here. Okay, now let's go back to what we're doing. What is our f of x for this example? It's just 2x. Can you see that? My f of x is just 2x. So I'm going to go minus the square root of 1 minus 2x all squared. Okay. So now here is going to be f prime x. What will I write down here? So let's go back. I can see some of you are looking like this is maths literacy. Is that maths literacy here? Okay, this is real maths. So you look here, f of x, and the formula is f prime x. Okay. So what is my f of x here? It's 2x. So I think maybe even a maths literacy student will know that the derivative of 2x is 2. Straightforward. Okay, compared to how it was done in N5. So here, minus 2 divided by the square root of 1 minus 2x all squared. That is how you apply the formula. You can square this here. Let's square it while we're here. That's minus 2 divided by the square root of 1 minus 4x squared. Now, we are ready to apply the formula. So, how does the formula work? It's going to be f of x, g of x minus the integral of g of x times f prime x dx. So what is f of x? My f of x here is inverse cos 2x. What is g of x? Remember, g prime x was x to the power 0, which is 1. G of x is just x there. Clear with that? So there's f of x times g of x minus the integral of g of x times the f prime x part here, which is minus 2 divided by the square root of 1 minus 4x squared dx. So now what you need to do is refer back to that example there. I'm talking about the simplification. So this negative times a negative, you can bring the 2 there if you want to, or you can leave it here. Let me give you a few minutes to do. This is the N5 part now, the integration part, whether it's type A, type B. So try it out first and then you will learn something. If you're watching the video, then obviously you need to pause, you need to try this one out before I do it. It's an important example, this one. Alright, so type B, the previous example, the numerator was an exact derivative of the denominator. Then last week we dealt with an example, I'm not sure if we dealt with it, but it was type A, I call it type A, where you have k and then you have f of x to the power n multiplied by f prime x. Okay. So this deals with multiplication. The previous example dealt with a fraction, which is division. So here n must not equal to -1. Okay. So if n is not -1, then this rule works. So how does this rule work? If you have f of x multiplied by the derivative f prime x, by inspection the answer will always be f of x to the power n plus 1 over n plus 1 plus c. That is type A, deals with multiplication. An example, if I ask you to integrate, let's say, sine of 2x to the power 5. Okay, let's make it just sine x for now, make it simple. And then plus 1 there. And then I got cos x here. Okay, so this is an example of type A. So you read this now, sine x. And then, okay, this plus 1 is a separate term. Let me just write it down properly. So that is sine x, and then I got plus 1 there. So inside the bracket, you have sine x plus 1. Then this is being multiplied. Okay, this is raised to the power 5, but it's multiplied by cos x. Now I need to check. If I differentiate everything inside here, is it equal to cos x? Yes. What is the derivative of sine x? It is cos x. The derivative of 1 is 0. So this is an exact derivative. That means this is f prime x and this is f of x. Then if you have this situation, k is just a number in front here, like 2 or 3 or 4, then it will be k times f of x, which is sine x plus 1 to the power n plus 1. So if this is a 5 plus 1 will be 6 over 6 plus c. And that is by inspection. If you understand how to do this, then you do it by inspection. Let's do another one here while we're at it. So let's say the integral of sine 3x to the power, let's go minus 2, and let's make this cos 3x dx. Now, let's put a number. Let me add a number here, like 5. So now you're reading this. Okay, this is inspection I'm showing you, not U-substitution. So you check everything inside here, sine 3x. What is the derivative of sine 3x? Is this 100% exact derivative of sine 3x? No. There's something missing there. What's missing there? What's missing there is the 3, because the derivative of sine 3x is cos 3x times 3. You don't know that, so you got big problems. You must know that the simple thing. The derivative of sine 3x is cos 3x times the derivative of 3x, which is 3. Okay, so now what's missing there is the 3. So if I have to write down a 3 there, in order for me to cancel it out, in order for me not to change the question, that's a 3, so I must divide by 3 also. Because 3 in the numerator, 3 in the denominator cancels each other out, and I get back to what it was originally. Okay, so now I have a situation. I got my f prime x, f of x, k is just a number in front, and I can go and integrate straight by inspection. That means I'll write down my answer now, so that will be k, so there's my k here, f of x, which is sine 3x, n plus 1, minus 2 plus 1 is minus 1 over minus 1, plus c. You're done. Obviously you can simplify, but simplification is up to you. The main thing is you recognize that this was type A and you could integrate it. Alright, that is by inspection. But now, if you're not familiar, if you don't know that there's supposed to be a 3 and all that there, don't even try this here. Don't try it, because what happens if it's 4 marks, you just write down the answer, your answer is wrong, you're getting 0. So then it's best to use U-substitution. You can always let U equal to f of x. Alright, so why am I showing you this here now? Let's have a look at what's happening here now. Let's go back to this example. So now we got x times inverse cos 2x Negative times negative, positive 2. And now, here's my, if I take this to the top, it becomes 1 minus 4x squared to the power minus half times x dx. So this is type A. It is not type B. Okay, it is not type B. So if you left it like this here, let me just say, if you put a 2x, or even leave the x up, let's leave it like this here, 1 minus 4x squared. And if you thought that this is a fraction where the numerator is a derivative of the denominator, that means you are completely wrong now in the way you're thinking, completely off. Because what is the denominator here? The denominator, this is the denominator here, alright? So this is the denominator. So let's take the denominator, let's call it y. Let's say if I got y is equal to 1 minus 4x squared. And if I differentiate the denominator, how do I differentiate something like this here? How do I differentiate the square root of 1 minus 4x squared? First of all, this is going to be 1 minus 4x squared to the power half. I did not differentiate it, I'm writing it as a power of half there. So in order to differentiate this, I need to use the chain rule because I have an exponent which is a number. So then 1 times half, which is half, 1 minus 4x squared, half minus 1 is minus half times the derivative of 1 minus 4x squared is minus 8x. Does this look like everything here? No. So it's definitely not the previous type. It's not type B, this is type A. So therefore, you must take this to the top and make it multiplication now. Can you see that? So be careful. You have to know your N5 differentiation 100% before you even come here. Otherwise, you're always going to get stuck. You won't know what to do. Alright, so now, let's get back here. I'm going to use the method of U-substitution. So I will use U-substitution. So with U-substitution, always let U equal to f of x. So I'm going to let U equal to 1 minus 4x squared, which is the f of x part. Then du over dx, the derivative of 1 minus 4x squared is minus 8x. Now I need to make dx the subject of the formula. So then dx is equal to du divided by minus 8x, and now substitute. So there's the substitution now. So I got my bracket there, I got my negative half, and I got x. So now I am replacing 1 minus 4x squared with the letter u. So there's my u here. And I'm replacing dx, there's my dx here, with du divided by minus 8x. So when we use our u substitution, you notice that the variable x is now out of this problem. We are now integrating with respect to the variable u. So let's copy this down. This is equal to x times inverse cos 2x. What is happening now? We can see x and x cancel. So I got u to the power minus half du, but don't forget about this fraction here. You got a positive 2 on the top, a negative 8 in the bottom. So you got 2 on the top, divide by minus 8. You can work that out on a calculator if you want to. This is the same as minus 1 over 4. Alright, so write down your fraction or the number in front here, so it does not interfere with anything that you're dealing with. Now, straightforward. Now, you're going to add minus half plus 1, minus half plus 1, and you're done. So let's do it. So that will be x inverse cos 2x minus 1 over 4. And now we can integrate that u to the power negative half, which is going to be minus half plus 1. Okay, minus half plus 1 is going to be half. All divided by half plus c. So we're done. The problem is done. I'm just going to simplify it. So therefore, I got x times inverse cos 2x. This is minus 1 over 4 times 2 over 1. Remember, I'm dividing by half. So if I bring this to the top, I need to swap numerator and denominator there. So it will be times 2 over 1. U to the power half is the same as the square root of u. Plus c. You're done. Don't forget to substitute back for u. What was u? What was u? U was 1 minus 4x squared. And that was our inverse trig. Integration by parts. You must know it. Okay, if you think this is hard, you're doing the wrong course. This is only chapter 2. This is the easiest thing that you're going to do in the whole of N6. Okay, so don't think that this is difficult. This is easy. Alright, so integration of trigonometric functions. This you will find easier than integration by parts, but certain examples might take you longer to write down, but the difficulty level is not like that one. It's not higher. So we need to integrate up to in N6, sine to the power 5, cos to the power 5, tan to the power 5, and cot to the power 5. Okay, that's the N6 one. Let's go back to N4 and integrates. So I want to integrate, this is standard integrals. You will find this on your formula sheet, talking about something like this here. So if I want to integrate k sine bx, remember k and b are numbers. Okay, k and b are numbers. So if I want to integrate sine of bx, then the formula to integrate sine is, we've been dealing with it. It is minus cos bx all over b plus c. Okay, that's how you integrate sine. So now here's an example. I want to integrate 2 sine 3 over 2x. So the formula to integrate it will be minus cos 3 over 2x. So the coefficient of xb here is 3 over 2. There's my b there, all divided by 3 over 2 plus c. That's a standard integral. I'm going to simplify this. That's going to become minus, if I swap numerator and denominator and multiply 2 over 3 times minus 2, I'm going to get minus 4 over 3 times inverse, just times cos. Alright, while we're on this here, if I ask you to integrate now 2x sine 3 over 2x dx, there's a difference now. Can you see that? There's a difference between this example and that example. This is integration by parts, because you got the variable x here now. Can you see that? It's not just a number. It's the variable x multiplied by sine. So this is integration by parts. That is not. So that is integrating sine. Now let's take the next one. Let's go for sine squared bx. Okay, so now sine squared bx. I'm just going to show you here quickly, although it's not required, but I just want to show you how do you get this formula in. because many students get confused, and when you say sine squared, you think sine squared plus cos squared is equal to 1. We are not using the square identity here. We go back to our trigonometry, double angles, and remember the formula for cos 2x. The formula for cos 2x, your double angle formula. There's three formulas, three ways you can write down cos 2x. It's cos squared minus sine squared, 1 minus 2 sine squared, and 2 cos squared minus 1. Those are the three formulas, double angle formulas for cos 2x. Now, the focus is on this one here. Why? Because this one has sine squared in it. Can you see that? Now watch it. If I got cos 2x is equal to 1 minus 2 sine squared x, and now I also have sine squared here, so I want to make sine squared the subject of the formula here. I will take this, make it positive, so it becomes 2 sine squared, and this one here, take this to the right, 1 minus cos 2x. Now all I have to do is divide by 2. So therefore it's going to be sine squared x is equal to 1 minus cos 2x all divided by 2. So this is the formula that I'm going to use. It's given to you on the formula sheet, but not like this. It's given to you as separated as 1 over 2 minus cos 2x all over 2. That's how it's given to you. Same thing, it's just that it's separated into two fractions here. Can you see the difference between that and that? Now, this is the formula. Notice what is the angle here? 1, and here it's double 1, which is 2. Let's see, let's look at it. 1 and this double 1, which is 2. Now, you need to take note that it will not always be 1. You're not always doubling 1. So it can be anything. So let's go sine squared 10x now. So if this is replaced with 10, then the formula is going to be 1 minus cos. Whatever this is, you are doubling it. So therefore, if this is a 10, what do you get here? 20. So it's going to be cos 20x all over 2. Now let me write it down for you in general. This is coming from the double angles. So sine squared, let's call this, okay, it's given to you like this on the formula sheet. I'm going to write it just like how it's given to you, so you won't get confused. So it's given to you in this formula, half into 1 minus cos 2a. But it's separated into 1 over 2 minus cos 2a all over 2. This is what you see on page 1 under trigonometry on the formula sheet. Nothing to do with integration. This is trigonometry double angles. I want you to learn it this way. Instead of separating it into fractions, this is the best way to write it down, for a reason you're going to see in a few minutes. So now, here's k sine squared bx. So what are we changing sine squared bx to? It's going to be half 1 minus cos, and this is b. I must double b, in other words, multiply whatever you have by 2. So that's going to be 2b x dx. So now I got my, whatever number this is, k times 1 over 2 is just k over 2. And now I have two terms here, which are straight standard integrals from the formula sheet. I can integrate one. What will it be? With respect to x, it will just be x. I'm integrating now. The whole idea was to write sine squared in a form that we can integrate. So we integrate 1, it's x. Integrate cos, it's going to be sine 2bx all divided by 2b plus c. We're done. So let's take a real example now, because here you might get confused when you see k and b. So let's take an example like, let's put this as 2 over 3 let's write this as sine squared x over, let's make it a fraction, x over 3 also. Alright, so now if I want to apply this formula here, I got my 2 over 3. Now I see sine squared. Alright, so now make note that this is an even power. Okay, we are using the double angle formula when we have an even power, even number. Your exponent is an even number. Right, so what do? We go to our formula sheet, double angle formula, and we change sine squared into half, 1 minus cos double this here. Remember, the coefficient of x is not 1, it's 1 over 3. You should have realized that long time ago. Okay, this is not 1, it's going to be 1 over 3. That is the coefficient of x there. So when you double 1 over 3, it's going to become 2 over 3x. So you can't make any mistakes with these small things like I said. Right, so I doubled it. So now it's done. All I have to do is integrate the 1, integrate cos. These 2 here is just constants. Multiply that by that. What do we get? 2 over 3 times 1 over 2 is 1 over 3. Now, I'm not copying down the integration sign because I'm going to integrate now. I'll integrate 1, that will be x, integrate cos, that will be sine 2 over 3x, all divided by 2 over 3 plus c. You're done. I just want to simplify. So copy this down, and then I'm going to show you sine to the power 4 now. You can multiply the 1 over 3 inside. It's all unnecessary work, but in order to remove the brackets. Right, so copy that down quickly. Alright, so that was sine squared. Now we are dealing with even powers. Okay, your exponent is an even number. So 4 is an even number. So if it's an even number, we need to apply the same technique. Use the double angle formula for sine squared. Now we need to get sine squared. So we use our exponent laws. The exponent laws, I want sine squared because the formula applies to sine squared, not sine to the power 4. So therefore, I will write it as sine squared in brackets all squared. Can you see that? Because when you have a power raised to a higher power, exponent laws, you multiply 2 times 2 will give you the 4. That is exponent laws. Now inside the bracket is where I will change sine squared using the double angle formula that I just wrote down. So therefore, sine squared can be written as half into 1 minus cos, and it's a 5, so you double 5, what do you get? 10. You get 10x. Close bracket there because this is the formula for sine squared 5x, and don't forget that it's still raised to the power 2. So now the extra step that I have now is I need to square everything. So how do you square this? So remember, this is multiplication. Half is being multiplied by this. So when you apply your exponent law, it's going to be half raised to the power 2 and multiplied by 1 minus cos 10x raised to the power 2. That's exponent. You can see that? So now 1 over 2 all squared is the same as 1 over 4. This I need to square it. You can do it in one step. Remember, if you have a minus b all squared, it's the same as a squared minus 2ab plus b squared. Basically, you square the first one. Then to get the middle term, it's 2 times term 1 times term 2. Then to get the last term, it's the last term squared. We've been doing this from not sure what grade. Okay, so you apply it here now. So square the first one. That's 1. Middle term is 2 times term 1 times term 2. 2 times term 1 times term 2. That's going to be 2 times 1 is 2 times minus cos is minus 2 cos 10x. And in the last term there is plus cos squared. So cos squared 10x, close bracket. We're done with the squaring. So now check now. Term 1 is fine. Term 2 is fine. The problem is term 3. Term 3 has the square there. Now, from your double angle formulas, okay, remember that cos 2x is equal to 1 minus 2 sine squared. We use this one, but the other one is 2 cos squared minus 1. That is it. I just wrote it down there now. So now the focus is on this one because of cos squared. Now, can you see that? This formula has sine squared in it. Double angle formula, this one has cos squared in it. So if I have to make cos squared the subject of the formula, take minus 1 to the left, so that's 1 plus cos 2x is equal to 2 cos squared, and then all I have to do is divide by 2. So 1 plus cos 2x all over 2 is equal to cos squared. So notice the only difference is the sign for the double angle formula I'm talking about. If it's cos squared, it's a plus sign. If it's sine squared, it was a minus sign. You can see it. So in general, let's write down the formula here. So that's going to be cos squared A. This is how it's given to you on your formula sheet. So that is half to 1 plus cos double A there. So it's separated on your formula sheet like this, but I prefer you to write it down this way, not this way. So we need to apply the formula here now. So that's going to be 3 times 1 over 4, which is 3 over 4. Then I got 1 minus 2 cos 10x plus cos squared 10x now. Apply the double angle formula there, which is half into 1 plus cos double 10, you get 20x, close there, dx. Don't forget to close your brackets there. Now, just simplification here, remove the brackets. So that's going to be 3 over 4, 1 minus 2 cos 10x, and then half times 1 is half, and then half times cos of 20 is going to be half cos 20x. So now, what can I do? There's nothing more except just the 1 and a half. I can add it up. Can you see that? I've got 1 plus half, which is 1 and a half, which is equal to 3 over 2. Minus 2 cos 10x. And the last term is plus half cos 20x. So now, there's nothing more I need to simplify. So, you might be wondering now where the 3 over 2 came from. So you can take your calculator and you can add it up. It's 1 plus half. 1 is the same as 2 over 2 plus 1 over 2. LCD, 2 plus 1 will give you 3 over 2 straight. And now let's get back here. That's going to be 3 over 4. Integrate 3 over 2. So now we're finally integrating. So that will be 3 over 2 times x. Because if I differentiate 3 over 2x, the answer is 3 over 2. Integrate 3 over 2, I get back to 3 over 2x. Integrate cos, that's going to be minus 2 sine 10x all over 10. Integrate this one here, it's going to be sine 20x all over 20. I'm done. Plus c. So I'm just simplifying my answer. That's going to be 3 over 2x minus 2 over 10. That's going to be the same as 1 over 5 be the same as 1 over 40. So it takes longer than integration by parts, but it's just a method to remember. You need to remember if you have an even power, what to do. If you have an odd power, I don't have time now for the odd power, but we will continue.